Facebook geht, ja, das schaut so. Schaut eine iPhone an. Die Oktopus Videos und also wenn die Serienschau basierend auf Physics-based software müssen
Okay, then welcome to this 5th edition of the Lakeside Talks, the autumn edition. I'm really pleased to see that this is starting to grow to an event that's happening regularly with old faces, new faces. It's great, honestly. And today we have 3 speakers for you with very different topics. So there will be a nice mixture between security, gaming, and machine learning. And I will just very briefly introduce the first speaker to you. No, I actually will just read there. So welcome Christian Bauer. He's doing his master's thesis at the university, so that's University of Klagenfurt. And he will be presenting parts of his master thesis. And I'm really excited where this will all lead. So take the stage.
Thank you. Hello, everybody. My name is Christian Bauer, and I will present to you machine learning-based adaptive scheduling in big data pipelines. So this is the overall topic of my master thesis, and I'd say we jump right into it. So the overview, what we're trying to do is, first we monitor the resources, and we use the gathered data to then make future predictions. The task is to predict the resource utilization of incoming tasks in big data pipelines. So of course, if you are a customer, you just want to upload your task to this some big data center, and then in some cases, you also have to define, okay, how much resources do your other tasks take? And there are multiple researchers that found out that most people overutilize those tasks, and a lot of resources could be saved if those would be corrected. So, yeah. And also we try to predict how the overall system will behave in the near future. So, for example, let's say on Monday at 3 p.m. always some tasks start up and takes so much time. So we have some kind of a pattern that is always reoccurring, and we try to predict that. So we might be able to say that, we know that at 3 p.m. a lot of resources will be needed. Let's start up a few more instances to be able to process all those tasks in time. So, but it runs on my data center, so why should I care about utilization? The scenario, as I mentioned, computing resources are often in those data centers managed by resource managers. So you basically load up your task with the defined allocation or requirements, like how much CPU is used, required, and memory. And the rest you don't really want to care about. So, and of course this resource allocator accepts those requests from the users and then tries to allocate them onto fitting devices. Then, the problem, as I already mentioned, it's commonly known and researched in academic, and lots of data is available, that most users try to get more resources or allocate more resources than are actually required. This is a problem, since if a lot of users do this, then of course the whole system gets loaded with lots of different tasks that could be trimmed down a bit, or the allocation could be trimmed down, and it could run more stable or also use less energy. So, and resource over allocation. So, as already mentioned, there are some researchers, like one part of my master thesis are based upon this. As you can see here, the above figure is the CPU utilization, or let's say the allocated one is the orange dotted line or dashed line, and the actual one is the blue one. So we can see even if we allocated approximately 30%, it would still be enough to finish all those tasks in this time frame. So we could save about 10%, maybe even a bit more, and would save some money and also free up some resources. The same is true for the memory. So here we have some tasks, and it just needs 20% of the memory available, but it allocates 50%, approximately 50%. So even 30% could be saved in this case. So, and this is because people overestimated how much resources their task actually need in a data center. So, and this is from the Google cluster. So they provide those data sets, and this was analyzed in this paper. Yeah, and as I already said, there's a large gap in between, which we could save up. So the goal of my master thesis is first to reduce costs, improve the availability of resources, and also increase the energy efficiency and balance utilization. So of course, if you have some resources that are loaded with lots of tasks, while others are underutilized and basically do nothing and are just running without doing anything, is also not that great. So we try to balance this utilization. And of course, if we manage to reduce the allocation of, let's say, okay, we know, okay, these tasks that are incoming actually require less resources, then we could reduce the costs if we well, shut down a few instances. And yeah, it's a win-win for everybody. So then I will just quickly go over the process loop of the application. So here we have this big data pipeline. There are some tasks that will later get allocated to these resources. And then these the state of each resource then gets sent to a monitoring and analysis component. Those are things like the current CPU utilization, memory utilization, like we saw in the previous figures. Also other things, but yeah, let's keep it simple. And this monitoring analysis component, well, first the monitoring gathers the data and then hands it over to the analysis section. This is the one that will predict first, okay, how much will the next incoming tasks from this big data pipeline require to be run on those resources. Also, it will try to predict how will the future be, or the utilization of the future, or in the future. So, and then this adaptation and action component comes into place, which, well, as we can see, it adapts the resources or the allocated, let's see, the described or the defined allocation of the resources, and this will be in some kind of loop, and we will try to make a proper prediction to save up resources if overutilized. And then this adaptation will then say, okay, we might even shut down some resources, start up some, or yeah, just basically say, okay, run those tasks on those resources. So it's a bit of a mix of a lot of things in the end. So, and to do all this, first we have to have a prediction model that is able to, well, handle this kind of data. And for this, we use the Alibaba GPU cluster dataset, which is a large dataset consisting of, well, a cluster with 6,500 GPUs on about 1,800 machines. And there are different types of machine learning tasks that you could run a TensorFlow, GraphLearn, PyTorch, and other machine learning frameworks on there. And they tracked first the, well, how much a CPU, GPU, and memory was actually used. And also you had to define how much you believe you require. So let's say you need 8 cores on GPU, or use, let's say VRAM, makes more sense. And based on this, they have the CPU usage then, and how much planned, and how much was actually used. And so based on this, we trained our model. And I talked a lot about the model without saying anything about it, or showing it, let's say it like this. This is like the machine learning model architecture we use. So here we have the input. This could be some 2D data like rows with, let's say, CPU utilization, how much is planned to be used, and so on. So what I told you, like we plan to use so much resources, and in the end we try to predict either how will the future be like, or also how much will a task actually require to be successfully run. So here we have the input, what I now mentioned. Then it will get transformed to be able to be handled by our machine learning core, which is in this case a long short-term memory model. This has a few transformations and so on. I won't go into much detail here. And then afterwards, the output of this LSTM model then will get forwarded to a few fully connected layers, so simple linear layers, until it gets the output in the end. And the output is, as I mentioned, is either based on the current state of the model. Will the utilization go up in the next, let's say, 100 seconds, or will it go down, or will it stay the same? Or if we just look into some tasks, how much resources will it actually require? For this, I have then two different LSTM models. And yeah, so the first one, the forecasting one, the one I called forecasting, is the one that will try to predict how the system will behave in the future. Like I mentioned in the beginning, will the utilization go up at 3 p.m.? Will it go down? And so on. This could be done then for the CPU utilization, memory, and so on, and also maybe runtime. Then the next one is the utilization model, which will train on the task itself. Like we allocated, or the user wants to allocate so much, but in actual it only required, let's say, 20% less. So it will be adapted to that case. Then maybe a short introduction to long short-term memory. As already mentioned, is the main prediction component. Then it is able to process entire sequences, which is, well, why I use it in this project. Maybe you also know these convolutional neural networks, which could be used for classifying single images and so. But this here really takes into account a whole time series mostly. Like you could also use it for voice or audio and so general time series. And it uses cells, so they are called LSTM cells, which remember recurring values. And it is some kind of recurring neural network, as an RNN. And because of this, it is well suited for predictions based on time series data. And what's also very cool is it was also a very deep one, was used in DeepMind's AlphaStar, which was used for StarCraft 2, compete in StarCraft 2, which is pretty nice. So, and I have a short LSTM example, so it might make more sense what it does. So first, it's an example I found on YouTube, which is actually quite nice. Let's assume you have a roommate that cooks every day, and he or she, well, is very consistent. So if one day, let's say on the first day, she cooks pizza, then we know on the next day ribs will be cooked. If ribs are cooked the next day, brownies are cooked. It's not a very healthy diet, but that's what it is. So, and we tried based on the knowledge of what was cooked yesterday. We tried to predict what will be eaten tomorrow, or today in this case. So assume we ate pizza yesterday, then we know, okay, today is ribs day. Same if we know, okay, yesterday was ribs day, today will be brownies. And if yesterday was brownies, today is pizza day. And then if we spin this one further, so this is yesterday, today, then we can also use in this model the predicted values of yesterday, and also use this for today. So, and what the idea behind this is basically if you, for example, missed some dates, let's say you were on vacation the last week and you have no idea what will be for dinner today. So, and you don't have this data, you try to unroll the predicted one until you have an actual data point again, and then go back from this. And here, so this is the new information. So in this case, the data that was from yesterday, then the prediction of yesterday, the prediction of today, yes. Sorry, the animation is a bit wonky. Then, of course, we have this prediction. And as I said, this prediction is also used for this. So we could then, with this prediction, we could start to calculate into the past until we have some data points and go forward again, which is actually really nice. And also what in the end I use, so let's assume we have some tasks, like we always know, okay, let's go maybe one back. Let's assume the pizza is some kind of encoding, like we have in our cluster. The first step is always an encoding step. Then the next one is, okay, after the encoding of this some video data, we try to classify some objects, like we will try to, like cars or something, like is there a car in there also, and train on it or do an inference. And in the last step, let's say we want to store this new trained model on some S3 bucket in AWS or so. And if we then look into the data and see, okay, we just did this one, like not the ribs, but the training, then we know, okay, next the model will be stored on some S3 bucket. And based on this, we also know, okay, approximately we will require so much memory, so much CPU, and so on based on this. So we could, based on this knowledge, already see that, well, then we need to allocate so much resources to store it or make brownies for the next day. You could also say, okay, if we ate ribs today and the fridge is empty, you need to buy the ingredients to be able to prepare it in time. So, and here's some data of so far. So this is my forecast LSTM output. So this is, as already mentioned, based on the Alibaba GPU dataset. And here you can say this one is for runtime. Like here, I just look into, okay, how long will those tasks run on those machines? And the black one is the actual data, and the green line, I hope it's visible from the back, is the predicted one. And as can be seen, in some cases, there's a reoccurring task, so we could predict that, well, there the runtime will be higher. And it's also happening here, which is quite nice, here and here. Those are good points, but also the model still has to be improved. since we can see here, this one was not predicted at all. This could be either that it's a completely new one, or it was simply not detected by the model or forgotten. And also, not so nice is the detection of this one. So it's simply a prediction of a very long-running task that was actually not a really long-running task. So it still has to be improved. And this brought me to the idea, okay, well, this one alone might not be sufficient to make the decisions upon. So that's why I also found this paper, as that I already mentioned. And they used, this is the one I call this Utilization Lstm model. And I found a paper that used also this Alibaba dataset and very similar tries to predict all this. And as you can see, here again, the red line is the actual data, and the dashed lines are either the predicted allocation or the actual allocation that was happening. So, and what they found is if they don't predict the allocation, they used so much more resources than were required. And if they increase the cell size, so how long the LSTM model remembers features or values, the better the prediction got. The same is true for the memory. The only downside to increasing the memory size, because obviously if you increase the memory size, then the prediction is better, but it also takes more time to actually predict the data. So their downside was that they took quite a long time to make those predictions, which is obviously not feasible in a production setting. So I still have to figure out if this is also a problem for my case, but I'm also trying to improve the general execution time. Like, for example, if you have to standardize the whole data set over and over again, if you get a small portion, have to standardize it. I found that one of those very popular modules in Python is not very fast. And so I implemented one myself that was faster. And so it could be improved, but still, this is well, obviously something to look into. And also, they have this comparison. The gray bar is simply without using any prediction, how much was allocated. Then they have an RNN, so this the simpler version of a LSTM model, how much they could save up with this, and the memory size, memory cell size. And the LSTM was always a better predictor than either not using a prediction at all or using RNN. So there's a lot of improvement on resources not wasted, which is really great. And yeah, I hope to be able to further improve this one with using 2 models instead of 1. And so for now, the to-dos for my master thesis. The first one is finished utilization LSTM. In general, it is finished. I still have to, well, tinker around with the hyperparameters and so
So.
Super, weil so wie Karte
Nico, ist schon da.
Meine Fragen stellen.
Ja, bitte. Sehr.
Geht, oder?
Wenn du eine Frage so
Mitte oder
formulierst,
voll ausschlagen?
dass ich
Passt.
inferren kann, dass du das verstanden hast bis jetzt, ne? Funktioniert.
Hat vorher funktioniert. Das heißt nicht, dass es jetzt funktioniert.
Das ist true.
Magst du Wasser machen?
Komisch, wie du Bier sprichst, ja.
Soll ich dir bringen?
Ja, bitte. Ja. Das ist eine Quest. Ich trau mich nicht auf Extend gehen, Alter. Das haut sicher nicht hin. Das explodiert einfach.
Wir machen mal Mirror.
Der Christoph ist voll schlimm. Alter, jetzt habe ich gedacht, du sagst mal, da ist irgendwas falsch drin.
Tatsächlich.
Ja, ist okay. Ist nichts passiert. Mana, don't do it. Was ist denn jetzt los? Wollt ihr mich komplett fertig machen? Was tut? Cross-site Scripting machen wir da rein.
Okay. Well, then welcome back also to the online audience. The next talk is held by a colleague of mine. He's actually working with me in the same team. And so I'm really interested in if he presents well. Big question. No, I'm happy to welcome Christoph Wedenig, and he will present to you something about server-side request forgery, how it works, basically, and I'm hoping that we all will understand it.
I hope so too. Thanks for the introduction, Fith. So, hello everybody and welcome to my talk,
fancily titled An Adventure into the Realm of Server-Side Request Forgery. It may just not be that exciting, as the title may suggest. No, but you might actually learn something along the way, and I will keep it, as lighthearted as those tech talks can be. Just a quick introduction about me. I'm Christoph Wiedenig, like Veit already said. I'm working with him at Dynatrace, more specifically in the application security context, and also I did my master thesis on detecting server-side request forgeries in microservices. If you want to be cool, you actually can follow me on GitHub, because that's the only nice social network. So, short agenda. We're going to start off with an introduction. You don't have to have a security background to get that talk. So, we're going to start with the basics. We're going to talk a bit about the impact of server-side request forgery, why URL parsing is harder than you might think, actually, even though you see URLs every day and everything seems to work. Then we're going to go into some advanced techniques, and if the setup won't fail me, I will even show you an actual vulnerability in Gitlab, which even led to remote code execution. So, to get that out of the way, what's server-side request forgery? It's a web vulnerability, basically, that allows an attacker to make the server-side application do requests for him to some unintended location. Unintended here, very important. And you might know, like many applications that do stuff like that, like you ask that web server to make a request on your behalf, I don't know, download an image from an URL or something. And if you can make that web server touch intranet, so like access something for you beyond the firewall, so you're actually not supposed to be able to touch that, then this vulnerability is called a server-side request forgery, or SRI for short. So, obviously, where to find it? Like I already said, if your web application has an import from URL, there could be an SSRF in there. If you know Twitter thumbnails and Twitter post titles, they also get fetched by Twitter, actually. So Twitter does make the request for you if you enter a URL. So there can be SSRF in there, and I think actually there has been in the early versions of Twitter. Also, so in file processing, I will not go into that. That's a different kind. I actually learned that only when researching for this talk, that you can actually have a server-side request forgery in a video file. Don't know how that works. We're not going into that. And obviously also for reverse proxies or load balancer. So basically, wherever a server makes a request for you, there's a possibility of something being unsanitized, and you're gaining access to something you were not supposed to get. So there's three main types of SSRF, ranging from full blind to totally not blind. So just to quickly go over that, blind SSRF basically means you make the server make a request for you, but you actually don't get back whatever the server accessed for you. Pretty basic. Semi-blind SSRF means you get partial information, which technically is the case for Twitter, basically. So if you would find a SSRF in the Twitter metadata service, you could only get the information that they actually present to you. Or you can also make conclusions by response timing, which is a very clever way. Because if you make some service ping every port on a host, basically, you can deduce from the response timing which actually have something running on them, which actually gives you a lot of information as an attacker. And then, last but not least, definitely not least, the full SSRF, which is not very common, but some applications obviously give you the full response of whatever they accessed. All right. So what can you use that for? Like the obvious example in that case is you can access internal APIs or restricted data that you were not supposed to access, do some internal network recon like scanning ports, and more interestingly, Cloud Metadata API. If you guys if you start a EC2 instance, for example, in AWS, and you have the metadata v1 service enabled, it will bind this exact IP, so you can access this IP from the EC2 instance itself to get information about both the instance and your account. So actually, if somebody finds an SSRF in your on an application running on an EC2 instance, they can actually just access that API and extract your AWS keys, which is not very optimal. So they deprecated that. They actually did, because of exactly that issue. You can also do file read, which most people don't seem to realize. File is also just a protocol. And if the client on the application allows that, you can also read files from the vulnerable application. And last but not least, you can do remote code execution using other services like Redis, but we're going to talk about that later. So, if somebody said just disallow localhost or just disallow requests into the internal network, totally agree. If it would just be that easy. I made my slides actually interactive, and I have a really super nice example where you can vote for this URL, where the red boxes are actually spaces. What does your brain URL parser think is the host here? So if you think it's the yellow one, then raise your hand, please. So nobody thinks it's the yellow one. Green? Green? I think it's green. If I now say blue and nobody raises their hand, I'm going to be quite concerned. So you all think it's blue?
It depends, right?
It depends on what?
No, how the old passing is done.
Yeah, but what does your brain say to you? What should be the URL, like the host part of the URL?
I would say green because for the URL can have, for example, the company or something like password.
Yeah, exactly. The ad is very confusing, but if you raised your hand anywhere in this question, you were right according to some URL parser. So yeah, they actually don't agree either, which is very funny because yeah, this opens up the possibility, obviously, of server-side request forgery if you use a different URL parser for validating versus actually accessing the resource. And URL parsing is hard, and it makes a difference which parser you use for validation than actually making the request. And there is like this document, an RFC, that actually specifies how a URL has to be parsed, but apparently nobody wants to read that thing. It's so way too long, and everybody does their own non-compliant implementation. And here we are right now, right? So everybody's favorite programming language. Super quick example. You get the URL from the user. You use parse URL to parse it. And then you check the port needs to be 80 and the host needs to be example.com, and only then you read that. You use read file to read the URL, and otherwise you throw. What can go wrong, right? Foreshadowing. So PHP actually, the parse URL and the read file, they disagree on what the port is here. So parse URL will say, yeah, that's 80, it's fine, let it go through. And read file will read from port 1234. But that's only the port. And it would be oh no. Yeah, they also disagree on what the host is here. So like, I don't know what the takeaway is from this. Don't use PHP, I don't know. Full disclaimer, this is an old PHP version. I'm very certain they patched it. I hope at least. But you get the gist, you need to be aware of these kind of things. Another small example, this time from Node.js, and I had to make that stupid German joke, sorry, for the non-German speakers. They surely know that word anyways. So assuming you have a public files directly on your I don't know, on some page, and you let the user actually decide what comes after that, but you're a very smart programmer and you realize they're not allowed to use the 2 dots, because otherwise they would, you know, directory traversal up one, and I don't know, read something confidential actually. And that's technically also kind of server-side request forgery if you circumvent that check. And so obviously this doesn't work. Dot doesn't work. And now our best friend for this talk comes into play, and his name is Utf-8 Characters. And this is not just any n, yeah, not any n. These are, the full name is full width Latin capital letter N, and the hex representation is FF2E, and it's very relevant because Node actually didn't know how to, you know, handle Unicode in URLs, who has Unicode in URLs, and they just, you know, they only took the least significant byte, so they dropped the FF. So you see where this is going, right? Yeah. Guess what 2E is in Unicode or in ASCII, basically. So yeah, these are dots. And yeah, then you have directory traversal, which is quite a common theme actually with the Utf-8. You'll be surprised. People don't like to think about that. So those were some fun examples, but let's get on with some advanced techniques in like circumventing all of the stuff that web developers actually do to stop you from having fun with their applications. And we already looked at URL parser logic. This is fun, but there's more Unicode, and there's also different ways of encoding addresses, representing localhost, and also this new enemy IPv6. You know, software hasn't fully picked up on that yet. You know. So just also we have now actually Unicode in host names. They are allowed, and they made 3 different standards. You see the problem. They made 3 different standards of you know, converting host names with Unicode in there to the actual, you know, DNS lookup name. So everything's fine if you just go to google.com. You know, they all agree. But as soon as like you put in like this 200D Unicode, that's a 0 width character, and this standard will just say, yeah, sure, you didn't want to put anything in between. We sent it to google.com, but the 2008 standard will send it to this funny little URL, and yeah. Another funny German thing, obviously, the scharfe S, I have no idea what the English word is for that. That will also be transformed into SS with the 2003 standard, while it's some weird, like this is called Punicode, I think, for DNS lookups actually. But you see the issue, you know, if you actually wanted to circumvent somebody accessing WordPress and you would do a check for WordPress, how it's with the double S, how you would spell it normally, you could just circumvent it by, you know, putting that character there. And also each one's favorite characters from when social networks were in their infancy. This also can cause some troubles for URL parsers. You can make the lives of application developers even harder if you find out how you can actually encode your IP addresses in so many different ways, like in octal, decimal, hexadecimal, or my personal favorite, you mix all of them together to get this abomination. And I don't know, somebody has to deal with it then, you know. IPv6 is also funny. The top one is actually short for all zeros on port 80 in this case, so it will send you back to localhost if you put that somewhere. And the second one is actually I didn't even know that that works, but you can encode IPv4 addresses in IPv6 notation, basically. I don't know why you would ever want to do that, but it's possible, and people forget that it's possible. And this is very key. Yes. Also very funny representations of localhost. These all work. Try it. Please, please do. I especially love the last one. I didn't know that actually works. Just 0 is also very short, so if you don't like typing, the next time you just ping 0. More advanced techniques, actually, this time now you stop with all the IP shenanigans. You can actually just self-host some service, some server, like it runs on attacker.com, and if the vulnerable application is configured to, like you tell the vulnerable application, please access attacker.com for me, yeah, and attacker.com will just say, yeah, this is a redirect, please go here, and it's localhost. And at least I think most HTTP clients are actually configured to follow these redirects, and then this nice little web application will happily request localhost, even though attacker.com might have been, on the whitelist, or at least not on a blacklist. So your server-side checks for allowed hosts might be useless if you allow your HTTP client to follow redirects. These redirects actually can even change scheme, so this is even worse. So you could suddenly be accessing, I don't know, FTP or something. And you can avoid the redirect protection by using any of your favorite HTTP codes that actually are used for redirection. All right, more advanced. We're getting more advanced with every step. But you can also do some fancy DNS shenanigans and just pin any of your domains to localhost. Like in the first step, you would do attacker.com points to localhost. Say, please fetch attacker.com for me. We'll fetch localhost. Localtest.me is also a public host name that will actually resolve to localhost every time. And for all of your other needs, there's actually this utility called slip.io, where you can just put the IP you want in the wildcard subdomain, and it will just resolve to whatever you want. So this can be the AWS endpoint, whatever. And you can even take this one step further. If somebody actually goes as far as to check what the DNS resolves to, you can do rebinding, which is the worst nightmare of anybody trying to stop SSRF on their service, because if you actually resolve this host name for the first lookup, it will resolve to 1, 2, 3, 4, but every subsequent lookup will resolve to this. So this is like a great time of check to time of use vulnerability. So it will basically check is the IP allowed on the first time, and on the second time, when actually making the request, it will fetch something completely different. And to elevate all of this, until now you may have thought, yeah, man, what can I do? Just most likely with just a simple GET request on some internal resource, what can you actually achieve? Getting some sensitive data that is exposed without authentication, that's not very likely, right? Is it? But you can actually smuggle other protocols in your HTTP request. So these protocols are all text-based. So like Docker, MongoDB, Elastic is actually HTTP-based. And there's like the Redis protocol, FTP, SMTP, and Git. Those are all just text-based protocols. So you can just interchange them with HTTP. And this has a lot of potential for harm. The only thing you do is actually you need a new line in your HTTP request. And then you can put in some other, like this, for example, this will, if sent to a Redis instance, it will set some key value to true. And this vulnerability is called Clrf injection, so carriage line return feed injection. And it's not, most people don't see it as very serious because it's quite harmless, but combined with an SSRF, you can actually get most of the time, very bad things to happen, because suddenly, with your innocent HTTP call, redirected towards some database, and you just talk to the database, and you, I don't know, drop table, whatever you want to do. So I have a short example of a Clrf injection in HTTP client from Apache. So they are vulnerable to CRLF injection, and you'd be surprised how it works because I think you already know they actually remove new lines correctly, but those two characters they have struggles with it. And if you say, oh no, is it the same? Yes, it's the same. It's exactly the same as Node.js. They just copy the least significant byte because they don't check for Utf-8, and suddenly, you know, if you have some 0D, 0A, like characters that end with that, you suddenly have carriage return new line. Sorry, skip that animation. But you get the gist, right? Then suddenly you have a break in your HTTP request, and boom. I will just finish things off with this Gitlab demo. So they had a big exploit in version 11.4.7, because Gitlab has a fancy feature where you can import another repo using an HTTP, HTTPS, or Git URL, and they forgot to actually check for the IPv6 format that houses an IPv4. So you can actually use to talk to their Redis, and funnily enough, GitLab uses Redis internally to handle like jobs. So they have a job runner that checks Redis, is there a job to run, and there's, fancily enough, there's a GitLab shell runner job type that you can just write into the database, and the job runner will happily pick it up, run it for you, and yeah, then you have remote code execution. So, really hope this doesn't break on me. So I have actually a local GitLab running. I hope this is big enough. And you can go into new project, and you can do import project, repo by URL, and let's just try putting localhost there, like 127.0.0.1 something.git. It's just, you know, whatever, something. It has to be unique. You try to create that project. I think it will. Localhost is not allowed. So they actually thought of, at least they thought of this, you know. But they didn't quite catch all of the fancy ways you can disguise. So actually have some payload prepared, which we may have to explain for a second. Oh, that's a bit complex. Without the encoding. So this is a small little payload. You actually don't need to pay attention to all of this in between. But if you look at the top, we actually request localhost, but in IPv6 notation on port 6379, and that's actually, if you don't know, that's the default port of the Redis key value store. And afterwards, we'll just, from here to there, this is basically just write this job into Redis and let it execute. And it will try to, in this case, we'll try to run this from here on, we'll try to run this command which will just access this host name at that IP and open a reverse shell. So this can be anything you want, obviously, but I have it running in a Docker container, so this is very convenient. So I'm just gonna start a listener on that port, and maybe you have to URL encode it first, but I did that beforehand, so you have to, the new lines, obviously, they have to be URL encoded. I didn't mention yet, like they actually also don't, they ignore if you do have new lines in the URL encoded. That's totally fine for them. They don't care. So we just take that and just copy it. We just paste it in there. Whatever, we don't care. And then we're gonna start netcat listener on port 1. Oh, that's pretty bad to see. And now we're gonna try to open that project. I really hope this works. Docker networks, they really don't like me. Every time I change network, it just, yeah, it worked. So it actually already ran, and now I have a shell open on this box. So whoever returns Git, just gonna zoom in if that's possible, and I can ls/. So this is basically etc.gitlab, I think exists, yeah. And we could just be a sneaky guy and just extract all of the GitLab secrets. It's called GitLab secrets. So yeah, if something ends with end RSA private key, you're very likely not supposed to see it. But yes, so this is just the proof that this actually occurred in production, and it actually also occurred in GitHub as well, on the enterprise version of their software. Yes. This is just another quick look at the payload, because it was very hard to see previously. Yeah, so this is the IP, and all of this is just straight up Redis commands. And Redis will just straight up interpret everything correctly, and the gibberish that the Git protocol sends at the start, it will just happily ignore, because invalid Redis commands. Very nice. All right, that's it. That's it from my side. Thank you guys for listening. If you have any questions, please feel free to ask.
What would happen if we disallow anything but ASCII?
Anything but ASCII. So like cancel UTF-8. I mean, I think foreign speaking people would be very upset with you right now. But maybe sometimes it could make sense.
I mean, for encoding, do you think that would help?
I think it would help if we settled. The problem is not as much with UTF-8 itself, but it's with handling. You have to. People actually built their software originally not with UTF-8 in mind, and then suddenly it cropped up, and now all of these bugs are running in because people, they don't adapt. They have to. Yeah, I mean, it's hard. Like in a URL, I would agree with you. Like why have UTF-8 characters in a URL? But then at the end, people want emojis in their URL, so.
We have to pay the price.
Yes, that's the price you have to pay. Just don't have bugs in your software. How hard is it?
Okay. Well, you have the chance to ask questions later with Mahoney and Sturm as well, so feel free
nice.
to ask him questions that might pop up in the next couple of minutes. Again, I would propose a very small break just to switch setup, and then we will hear the third and last, but definitely not least talk for today, and see you back in some 5 minutes. Ja, passt. Hast du schon probiert? Nur damit wir eventuelle technische Probleme rechtzeitig abfangen können.
Weil beim letzten Mal hat uns der Beamer versagt.
Okay.
Oder der Splitter. Oder das Kabel. Oder wir wissen es nicht.
Ich habe jetzt mal auf Duplicate getan, aber
Mal kurz. Ah, was hast du für Auflösung drin?
nein, ist ja Full HD.
Okay, Full HD sollte kein Problem sein. Schaut ziemlich schwarz aus.
Ja, sollte eigentlich nicht schwarz sein. Ha. Was ist da los?
Ah, was?
Jetzt habe ich auf Extend getan. Aber irgendwas ist da auf der rechten Seite, aber es ist irgendwie nicht. Bildschirm.
Ah, na, schau.
Jetzt ist es da.
Jetzt sind wir da.
Probier auf unter 4K, weil für mich da.
Ich habe kein 4K.
Nein, ich weiß, aber er glaubt, das, was du ansteckst, ist 4K.
Okay.
Und der Beamer schafft kein 4K, weil der
Ja.
HDMI-Splitter unterstützt 4K und sobald ich es
Aha.
umgestellt habe, ist es angesehen.
Brauchst du Sound?
Äh,
Ja, besser mit, nehme ich an.
wenn ich das Spiel herzangen, das Spiel läuft, das herzangen kann, ja, aber irgendwie will das gerade nicht, laufen. Ich dachte generell nicht gut auf meinen Laptop, aber
Ja, wir haben noch 2-3 Minuten.
ja. Das ist komisch. Mal starten. Nur, dass ich aufgehängt, wo ich gestartet habe, aber
Ja, passt. Sonst probier's mal nicht zu starten, mach den Talk, da bringen wir dann und dann können wir nochmal
okay, machen wir so.
mit Sturm und testen.
Wird neu gestartet, super. Warum startest du Teams? Aber es ist nicht. Ich verstehe es nicht. Warum er Teams starten will. Wo ist nicht in den Startup-Apps drin? So, okay. Skype und gucken, mal schließen.
Es ist Microsoft. Hast du noch absichtlich mit Extended oder?
Nein, ich habe eigentlich mit Duplicate.
Er hat wahrscheinlich wieder die Auflösung.
Das haben wir so wahrscheinlich.
Auf Display.
Das ist einfach Windows 11.
Ah, das ist. Okay. Ja, das muss sein. Ja, dann mach nochmal auf Extend. Ich glaube, das hat vorher funktioniert. Jetzt stellen wir die Auflösung nochmal ein. Ja, es sieht nach 4K aus.
Ja.
Ja, genau.
So, was sind,
Jetzt soll es funktionieren eigentlich.
irgendwas ist da draußen. Aber.
Auf Duplizieren ist es, oder was oft bei Windows F10 oder was ist?
Na, wir haben jetzt einen Extender getan, weil Duplizieren eigentlich nicht funktioniert hat. Das war ein Extender gehabt, da haben wir auf Duplicate gegangen.
Was haben wir so stehen?
Aber kein Signal.
Kriegst du immer nicht, oder?
Kein Signal von deiner. Von oben.
Ich steck das nochmal aus, gell? Schau nur nochmal Nico hinten. Was ist einfach mal so?
Er macht irgendwas. Er kennt ihn, aber.
Das bringt sich raus.
Das hat ja gerade funktioniert.
Jo. Na?
Das hast du jetzt alle Varianten probiert.
Ja, ja.
Ja.
Wir haben auch die Auflösung manuell runtergedraht. Also.
Vor haben wir eigentlich auch.
Mach mal nur externe. Das darf jetzt schwarz bleiben. 3, 2, 1. Na?
Wenn du jetzt ein komplett neues starten würdest, wird es wieder so lang brauchen, oder?
Das haben wir gerade gemacht.
Wir haben gerade neu gestartet, weil.
Dass alle Tricks schon.
Das war der Fehler, ich sag's dir. Nie neu starten.
Na, normal. Weil es muss jetzt erst bei Nico ankommen, bevor es da aufgeht. Ich meine, wir können mal. Kurz was anderes putzen.
Okay, Ich denke nochmal ab.
Es ist halt ein Notebook, was. Gute Idee.
Probieren wir es
Das haben wir
nochmal.
erst probiert, also deswegen habe ich es umgesteckt.
Was ich noch probieren könnte, wir hängen wir nochmal direkt zum Projektor.
Ja, er macht da irgendeine komische Zoom-Animation.
Er kennt schon, dass das zweite Display da ist.
Ja, ja, das erkennt er ja, aber.
Wobei haut sich aus, aber
Zeigt das dann 1 auf 2, gell? War nicht so. So gesehen.
Genau, jetzt haben wir gerade Duplicate, jetzt sagt er 1, 2. Aber
man, wir können direkt zum Projektor mal hängen, da können wir halt den Stream vergessen, aber vielleicht funktioniert es
schon.
Ja, man muss
Ja, genau,
Ich
so haben
mache jetzt nichts
so
mehr.
haben wir ja geredet. Das ist
Naja, Laptop muss ja. War ja mit einer Grafikkarte an der Quelle.
auch reicht wenn es einen halben Meter und jetzt steht.
Okay, das reicht. So. Und jetzt weg damit, brauchen wir nicht. Da war nicht Zeit. Okay.
Then, welcome to the third talk of today. So we started with machine learning. We had a small intermezzo of cybersecurity, and now we stray directly into the gaming sphere, or the game development sphere rather. And it's my pleasure to welcome, well, the person that I actually know as Fire Totem Games from previous events such as the game jams, where you take part quite often. Welcome Sebastian Ut. He will present how he arrived at the current, is it a product? No, it's a demo, right, of your current game?
Yeah, right now we have a demo, but this is planned to be our first commercial game that we release. So we have done a lot of game jams. And yeah, I will talk about the journey that resulted from this ugly blob on the left side to the spider on the right.
Okay, well done.
So, hello to my talk, game dev journey from a four-legged monster to a realistic spider and dynamic spider webs. As already mentioned, my name is Sebastian Witz. Yeah, small introduction. I have a Master of Science in Systems Design from the FH Kärnten. I worked at Infineon as a firmware designer for 6 years, and I started with game dev in 2017. We are self-teaching, so Googled how to develop games, YouTube videos and everything, and then I started the Game Studies and Engineering Master at the university in 2019, and I'm currently working on our game, A Webbing Journey. And yeah, down there, Fire Totem Games, that's the name I released my games on. And it's not only me anymore, I have two colleagues, which are not from Carinthia, but from Austria, which are not here today. Maybe they are in the stream, I don't know. And yeah, we are working on our game now. So how did it start? So everything started last year in June, where I decided to make several tutorials on game development because I had some low motivation. I wanted to do some stuff, learn some new stuff. I had a long list of stuff I wanted to look into. And yeah, combined with that, I also tried to post on Twitter what I have learned each day. And one of the days was procedural animation. And basically, it started with this 1-minute video on YouTube, which is just a very simple, quick tutorial. Does not show you any code or anything, just the basic mechanics like using inverse kinematics, then fixing the endpoint to the ground, then calculating a new target point, and then using raycasts. So this is one of many raycasts that are used in this demo or in my game, or our game. And then basically, yeah, you're checking if the leg has moved too far away from the target point, and then you just follow it along. And then, yeah, put more legs on, and you have not a spider yet, but this 4-legged monster that walks in a zigzag pattern, and yeah. So this was basically day 26 of tutorial June, as I have called it and tweeted about it. And after this one day, my little spider or monster looked like this, which is, it's working in that scenario that I'm showing. So you only show what is working, basically, not any other special cases. So moving it diagonally looks a little weird, but it was a start. It's a really complex topic, actually, to get everything right and then working. And yeah, this was progress on day one. I then broke my rule of doing a different tutorial each day because I really liked it and I was not satisfied with the result on the first day. So I decided, yeah, let's get another day in and see how it performs or what I can get, how far I can push it. And basically it's where this short YouTube tutorial is at. So I also looked at other YouTube tutorials and papers and everything and tutorials to get a hang of it. And basically it can walk around on uneven surfaces, basically just with normal gravity, which is basically there's no gravity, everything every position is calculated, and the legs are searching for the best position, and as soon as they are too far away, they look for a new position and animate to this point, and the body is trying to orient itself to the surface. And then, yeah, I did some other improvements because I was not happy with the body rotation and everything, so that the body is having a smoother orientation based on the geometry down below, and the legs are also looking better when moving and the positioning. Yeah, this was the first 3 days, and basically, yeah, as it works, so the spider, the monster as it's in this state, the body is basically doing the heavy lifting, and in this example, it's casting 4 rays on each side, on each edge, and based on this ray and the resulting position, it orients the body in all directions, and also in the height, it sums up the resulting raycast points and then lifts the body up or down depending on what is the average. Basically, the body works without the legs, so the legs are just for show to connect the body to the ground. You will see it in the on the next slide, how funny it looks without legs. Yeah, and each leg is basically a single system that is working on its own and just trying to find a suitable position. And yeah, there are a lot of raycasts from the body, from the legs, and it also changed a lot how many raycasts are used in the system. This was the easiest version, that's the minimum amount of raycasts, and is also really using raycasts, and not as in the next slide where I changed to spherecasts, because raycasts in 2D are easy. In 3D it gets a little bit tricky because it's easier to miss any object that you want to hit. So first of all, you need, if you want to climb upside down, you need many more raycasts to really get all the possible edges, and if you want to go around an object, or if you have an edge like this and you go along it and the raycast is just straight down, then it does not register the edge. So I upgraded the system. I implemented more raycasts with different angles and lengths. As you can see down there, this is from the current system, which is basically came out with a lot of trial and error until it works. So the red ones are basically rays that are cast downwards. So we have some that are coming from the middle of the spider body going outwards, and some that are at a distance and go inwards to account for climbing around objects, and the other one is for climbing upwards. Then there are also is a fan of rays in front, which are detecting the objects in front of the spider, and also one sneaky ray that's going up in case an object is above the spider, to really register that as well if you have something of an overhang to get the spider around. And yeah, after implementing this, after trying a lot around, and in that version, the spider had way more raycasts because I wasn't sure how many I need. And yeah, I put the eyes on the front just to know where the front is, basically. It's now a stable of our spider, but yeah, back there it was just to have front and the back of my monster. And yeah, the camera is really wonky. This is the only time you will see the camera really following or rotating around like this, because I decided it's not going to work, just confusing everybody. And yeah, basically it works. You can run around this stuff. You can also go 90-degree angles, which looks a little weird because the camera is snapping. But yeah, this was the beginning of climbing upside down. And then, yeah, I put the legs back on. Hit play. And basically, yeah, the legs are, as already mentioned, a separate system that's just looking for the best position. In this version, it's not taking always the best one. It's kind of clipping through stuff, maybe. But it looks a little better now, or it looks not as creepy as just having the body, and it looks somehow realistic. And yeah, now we have 4 legs, but to make it a spider, it needs 8, so I just put 2 more in, made the body a little longer to have more space, and then, yeah, you get this. And you have a spider that can climb up stuff. And it looks kind of believable. And yeah, as you can see, the camera is also staying horizontal level, just to not completely confuse the user or the player. At this point, this was not planned to be a real game or anything. It's just playing around, having fun with this mechanic, and trying out how far I can push it. And yeah, next step was then, yeah, I skipped some stuff. So basically, the eyes got really goggly eyes. The spider has some animations or some emotes. It can jump, and at that point, I decided, yeah, let's make it into a game, give it a new environment to climb around, jump around, and yeah, also give it some Spider-Man action, because that's basically the simplest thing you can implement, just some hook shot or whatever you want to call it, some spring joint action in Unity, and yeah, made the game a lot more interesting immediately. as soon as you can do that, you also see some of the animation. So the spider can wave now and pop up and down and everything. There are a lot more emotes in the demo already. And yeah, this was the easy part. And then the idea came up here, you're a spider, why not also build spider webs? And yeah, this was the first iteration. Oh, we also have sound. I don't know if we need that, but let's not use the sound right now. So basically, very simple web. It's just a sphere collider or capsule collider that is registered as a solid object for the spider to climb on, like the other environment. And I have a simple 2-point system where you can, if it works, where you aim first point, then the second point, and then you can weave your spider web around and climb on it. What you notice here, the web is very static. So as soon as you make one thread, web thread, it stays there. And I think there was also no deleting in that. So as soon as I built one, it was there. And yeah, if you take some time, you can make cool stuff like this. Funny thing about the spider webs is that climbing on them worked immediately. So it was a no-brainer. It was like the general climbing code was good enough to make it work on these small objects and did not need much tweaking to actually work. And yeah, then the step was to make the spider webs a little bit more dynamic because they don't behave like real spider webs. And yeah, there was a lot of drawing involved. Like, what happens if for example, in this upper example, if I have this one and I put a new spider web in the middle, how does this joints have to work? So basically all the joints and all the threads, very complex system that everybody each knows who is connected to whom and how it changes depending on if there is a new one added. So if I add a new one here, then I delete this initial line and spawn a new line between those and the point there, and then just let this spring force apply. And then also other cases like, what if I attach two strings together, or what if I make triangle? And then also deleting, what happens if I delete lines, how do they change? And yeah, then after quite some work, it looks like this. So the webs are now really interacting with each other and getting pulled together. And yeah, as you can see, you can also delete them, or they will also be deleted afterwards. And yeah, this was quite a big step, and I'm quite happy with how it works. It gets even better with some new features, and yeah, the spider, of course, can also climb on it, which is working in this case. If there are some special cases in this version where it did not work. Yeah, and also deleting the web works. And yeah, deleting was also quite interesting because you could have some funny special cases where I had like floating web clusters in the air, which I don't know. Yeah, I'm not sure if they are in there yet, but it did not happen to me since. And yeah, as mentioned, the spider was not really able to walk on the web if the web was still moving. So if you stand on the web and you connect the web you're standing on to a new point and it gets dragged away, then the spider just floats in the air because the spider was not designed to work with moving objects. And the next big update was then to make the spider interact correctly with moving objects. And therefore, the spider got changed from using a kinematic body and calculating the position to really having a dynamic body that is able to interact with the environment. So maybe just ignore the funny text. It's just one of the many tweets I sent out. So yeah, so I try to come up with all the different ways of interaction, like having this blank that falls down, and you apply forces when you land, and when you jump on or jump off, and stuff gets like here. If you jump now, it gets pushed away. There was also this funny experiment with a seesaw. like to see how the spider is interacting with it. And I think the last one is then, yeah, okay, the spider gets then also. Yeah, spider then also got physics, so it really gets pulled back by objects, which makes it much more realistic than just standing there and dragging on it. You can bully your spider with the environment, so it gets pushed around by doors and other objects. And yeah, it tries to stay on the platform it's on, so if you have an earthquake, it looks kind of funny that the spider is trying its best to stay alive, basically. Yeah, that was this. And what was not working, so I'm, as mentioned, only showing what's really working on Twitter. So basically you don't show what's not working unless it's super funny. And I have some examples, but not in this presentation. And yeah, one last thing that was missing was that the spider is really interacting with moving webs. So basically, if you stand on your web, you can now connect it to a different point, and the spider is able to stay on it. So it sounds quite logical, but if you start developing something like this, you have so many special cases that, yeah, you have to think about. And yeah, in the same update, I also implemented floating objects, which make the world feel a lot more alive. So if you jump off of them or land on them, they get the force applied. And yeah, you can drag objects around with the web. And yeah, that's that. And yeah, one of the most funny videos is this one here, where I show off more of the web interactions. So basically what I did here was implementing a way to build your apps faster. So, and yeah, you can go quite crazy in the current demo and just make as many webs as your PC can run. And the spider should normally not fall off. So I have never seen it fall off in the latest version. And yeah, within 40 seconds, I think the video, you can make quite a mess on this demo island. And yeah. Yeah, one final look. And was also quite a good video on Twitter. Lots of likes and views. And yeah, if it works, I want to show a live presentation of the demo, how it's working, or how it's at the current stage. Just have to see where my mouse is. There it is. And I have to see if it's starting on the correct monitor, if it's starting at all, and if it's running on my shitty laptop. That's the next question. I don't know. I don't know why it does not want to run. It's weird. Okay, then let's continue with the last two slides. So basically, the journey on this game is not over. So there are some improvements still pending for deleting the webs. Right now, the web vanishes immediately, and the idea is to really let it just delete the thread you aim at, and then let the remaining web swing back, and then optimize it again and remove the web joins that are not needed. Yeah, the web is not really affected by the spider landing on it, which is also an update that makes it more believable. And yeah, the web is going through the geometry, and the idea is that it wraps around, but it's to be seen how, if this is really necessary, would add to the feel of the game. But in the end, we want to release the game, and there are lots of other points that we are working on, like the story, the dialogues, the quests, the level design, and yeah, the UI, everything. So let's see how much of this web physics are still getting in there, and how many optimizations we have to do to make it run And yeah, now we are at the end of the presentation. Thanks for your attention. Yeah, you can find me or us on Twitter and TikTok under Fire Totem Games. And if you search for our game, A Wagon Journey, on Steam, you can play the demo. Any questions?
What's the release plan for the game?
Release plan is mid of next year. So yeah, there's a lot of time that goes into making games, and I do the programming, project management, social media stuff, and my two colleagues, Manuel is doing the 3D modeling and level design, and Michael is responsible for music, sound effects, and is also writing the dialogues and the story.
Are you planning microtransactions?
No. One-time payment, 13 to 15 euros, something like that, and then a few hours of game playtime. And yeah, we presented the game at lots of events this year, like in Austria, we were at the Level Up Button Festival in Graz. We have been to the Vienna's Comic Con 2 weeks ago, and we also went to Gamescom this year with the game. And response in general, or the feedback is very positive. The game is attracting many kids, so who does not want to play to stop playing, which is a little bit annoying if you only have a few PCs, and others want to play too, but you cannot shoo them away because that's not nice. But yeah, lots of positive feedback, and parents like it, and yeah, it's open world. You can do a lot of messing around in the world, which appeals to kids, but also it appeals to a wide audience. It's a wholesome game, so it's no combat involved, and it's a nice story, and yeah, you're just going on your journey through different islands, and yeah.
Are you planning on expanding on other platforms on PC or?
Yeah, the plan is, of course, Steam, because it's the easiest as the first platform, and we will soon contact Nintendo Switch, or Nintendo to get a Switch dev kit. The game is running on the Steam Deck already, so that's not a problem if you have one. And Xbox and PlayStation, it depends if it's worth it, if it's profitable to port the game over there. Yeah.
So you mentioned that it will be open world and having a story. Will it also have some kind of puzzles or so? Because
Yes.
I could imagine that.
Yes, it's a 3D puzzle platformer, basically. So you have puzzles, you have quests that you get from NPCs or other animals in the world, where you have to use your spider webs to help them, like drag objects around, build webs, and open doors by pushing levers and buttons and everything, stuff like that. Yeah, and a lot to explore, a lot of hidden objects. So that's the plan. I would love to show you, but it's not working. But you can try out the demo at home. So.
How do you shoot webs now? Like, was the one video where you just like draw the webs? There was a
it's
example, right? Or do you can you only shoot webs from your spider body?
No, there are several systems. There's this quick build, where basically, if you're playing with the mouse, the left mouse button is basically dragging objects around or swinging. That's this web. And if you're standing on the ground or on any objects, with the right mouse button, you build the web from your position to the target. But you can also, with Q and E, you can also set the starting point, and then select the second point where you want to connect, and then drag this around. These two different systems with Q and E. The starting point behaves differently, and yeah.
Do you support gamepad's input?
Yes, full support already, and working great. So, but the first version of the game was not great, because you start with your game, you need a button for something, and you just take whatever is there, and you don't think about it. And for you as a developer, it's obvious to press that button, but if you are giving it to users, they are like, how is this working? What button do I have to press? And we optimized it a lot and also got this quick build feature in, which helps a lot of people. Because before that, you had to look down, set the starting point, and then set the second point, and then walk across the web. And now you just look there and press it, and you get the web immediately without having to look down, which is kind of annoying with the controller or gamepad. Yeah, so a lot of feedback that helped evolve the game, and also early on from Twitter, because we posted a lot of this on Twitter, so basically everything you saw was a post on Twitter. There are many more. If you want to scroll through, I would not recommend it. And the game would not exist without Twitter. So I put out these first versions of the spider and got feedback and got motivated to continue working on it. Like people asking, yeah, can it climb up the wall? And you're like, yeah, let's try it out. Cannot be that hard. Was harder than expected, but as always. But in the end, the game evolved, and yeah, I showed something on Twitter. People reacted. We got spiders can now wear hats, change the color of the spider of the web. Has emotes. Lots of funny stuff that just evolved from stupid ideas from Twitter. Okay.
I'm sure there's still plenty of questions, and you'll have the chance to talk to him again. But for now, I want to say bye to the online audience. Thank you so much. And to all of you here, there's going to be Maroni in a brief second. First, I would want to invite all speakers back up, because we have a little something for you, like is tradition. So, yes, here you go.
Thanks.
Here you go. Thank you very much for joining. Thank you.
Thank you for the invitation.
Photo.
Excellent. Okay.
Good.
Thanks everyone for coming. If you want to keep this alive, please, if you have an idea for a talk, let me know. You can already let me know. Sadly, there's not yet a new date because end of year stuff and reservations and but it's going to be early next year in winter, so it's going to be a winter edition. If you want to present, or if you know somebody who could present something, please let me know. You can either reach me via Meetup, LinkedIn, whatever. Yeah, you'll find it, I think. Also, tell your colleagues, your friends about it so that we can grow a little. Then I'm pretty sure this will interest other people as well. But without further ado, there's chestnuts out there. And grab a glass if you want to have some Sturm, because there's also fresh Sturm for you. Well, I don't know if it's fresh, but it's definitely Sturm. And feel free to mingle. The room will be open for quite a long while longer, so if there's any questions, the speakers are probably here for a little bit as well. Okay.
Version zum Laufen bringen. Das war cool. Ey, der geht.
Jetzt geht's.
Jetzt geht was. Können wir was jetzt? Jetzt muss es nur auf flüssig laufen.
Jetzt muss es nur noch flüssig laufen. Auf integrierter Grafik.